let me move this over real quick. They talked about what's called a conjecture. That's just basically an educated guess. You're looking at a bunch of information. What can you make of it? Okay. Excuse me. You're looking at patterns. You're coming up with the next thing in the sequence. That's the idea. You know, if a pattern is going red, green, yellow, red, green, yellow, red, green, yellow, what comes after green? Or what's the 50th term? You know, can you figure out the pattern to do it like that? We actually have a pattern like that in Algebra 2 right now. Something called an imaginary number. Imaginary number, you guys don't know about this stuff yet, is the square root of -1. When you square something that's a square root, you get what's underneath the number. If I raise that to the third power, I get -I. Then if I go to the fourth power, I get 1. The pattern then repeats itself. So what we did here in my Algebra 2 class just a couple days ago, I said, what was I to the 53rd power? Well, instead of trying to write it out 53 times to find the pattern, we realized that if you just divide it out by 4, figure out what your remainder is. So our conjecture, if you will, for something like this, is recognizing a pattern, figure out the sequence. What we did is we took 53, divided by 4, 1, and there was a remainder of 1, which meant that this would simplify to being just I. And that's what we would do. What's what? I? Yeah. Oh, for in math, the I is written as a cursive lowercase I. That's how I draw it. So it's the same basic idea that what we're doing is it's an educated guess, and how do you find a pattern? Okay. And that's kind of what the first section was talking about, pattern recognition, and just using, looking at all the bits of information to come up with a statement. Okay. As we get into 2.2, we start talking about what are called hypothesis and conclusion. That's when we get into our statements, and that's kind of more stuff that you guys. I don't know how far you guys got through on that one in the video. I don't know why the video would work for some people, it did for others. I have no idea what's going on there. But anyway, what we're looking at here is writing things as what's called an if-then statement. For example, two angles are supplementary if they are a linear pair. Well, if I write that as an if-then statement, if two angles are supplementary, then they are a linear pair. What's the hypothesis and what's the conclusion? What goes with what? And you guys have all done this probably in your science classes. What's the hypothesis of this statement? The if part. Yeah. The if is the hypothesis. The then is your conclusion. If then. All right. If it's second hour, then you're in geometry. Well, that's indicative of you guys, but it might not be somebody else. So it all depends on wording. So as we get going into 2.2 and then a little bit of 2.3, it's a lot more vocab. I wouldn't say vocab, but I want to say more words than there will be numbers. Right? Excuse me. Oh. When you have these things called if-then statements, I like to use P implies Q. You ever seen that before? P and Q? If P, then Q. There's a old statement. Mind your P's and Q's. You ever heard that? That's where this comes from. Mind your P's and Q's. Watch your logic. Watch what you're saying. Okay. That's what that stands for. That's what that means. That's where that's an old adage, if you will, of how it came about. What happens here with these conditional statements and whatnot is, I'm trying to think of a real easy one. If it's second hour, then you are in geometry. Real simple statement. It's a real simple statement. Now, we're going to use this as our conditional statement for this case. We're going to say that this is true. And it's just true, obviously it's just true for our class, or if there's no geometry going on right now. But for us, could that be a false statement for somebody else? Yeah. And that's where a lot of this stuff comes back and forth. It depends on how things are written as far as if it's what we call a true statement. But for today, we're going to say this is true. Now, if I say this backwards, if I flip it, so this is P implies Q. If I flip it and say Q implies P, how would you say it? Close. We won't put the if and then in there. Yeah, you just forgot the if part. Yeah, but you're on the right track. Yeah, exactly. If you are in geometry, then it's second hour. Okay? We can just flip-flop it. A lot of times in math, they do this with definitions. You'll see if-then statements written pretty regularly in geometry textbooks. Okay? Now, there's a whole bunch of sequence of things that we're going to be talking about. Oh, let's do this one first. You've all heard this. If this had been an actual emergency, the signal would have been followed by official information. You know, when they do the, well, tomorrow, 10 o'clock, they'll have the air raid sirens going off. No. This treating words. I just wanted to say what part is the hypothesis of that statement? Yeah, if it was an emergency, and then the conclusion would be what would happen. Exactly. If there really was a tornado, they're going to tell you go to the basement and hide. Okay. If this was if it was an actual emergency, that's why they do those tests. And then you'll say, if this had been a regular test. I mean, do you guys even listen to the radio anymore? And sometimes on the radio, you hear it goes off. Why? Because we live in an area that you could have tornadoes. Oh, we do. We usually have one. We usually have one a year for like a weather drill. We usually do. So, what was it? I think it was probably about 13 years ago. 13 years ago, we had a tornado. It was like the first full day of school. Well, there's been other ones, but I vividly remember the actual time that we really did have to take cover was my first full day as a teacher. It was towards the end of the day. So school gets out at 2:45, and it was probably about 2:30. We were all at the old building down at what now is Huntley. And if you can imagine, you know where when you go into the Huntley, where the what do you call it? The gymnasium is, the gym, right when you walk in those doors there. If you go to the right, well, we're not in the locker room, but before you get to the gym, if you keep going to the right down that hallway that way, in that hallway, basically the entire school was in that hallway because that was the older part and it was just the lower level. Where it went west and then it turned south alongside where some of the old tech rooms and stuff are. They had that downward stairwell. So basically the entire high school is in those two areas. And it was, we remember, back then, there was no air conditioner or anything in there. So it was a real hot, muggy, humid day. And then storms rolled through and the air raid sirens were going off because there was a funnel cloud south of the high school on the other side of 88. I mean, south of 88 still, but it was close enough. But yeah, that was nuts. That was fun. Yeah, first full day we had actual, had to go take cover. We were fine, but then I don't know, you guys were probably still too young to know this, but then I think it was the next day that the rains were so bad that the Kish flooded up. They actually canceled school because the water got so high. It was just so bad. But we had a snow day the second full day of school. We had a snow day. Weird. If I want to turn this into an if-then statement, let's try that. It says perpendicular lines intersect. How would you write that as an if-then? There's a couple ways of doing it. Okay, what's another way I can say it? Yes. Which one sounds more correct? If their lines are perpendicular, they intersect. Why? Right, but you still turn it into an if-then statement. What? Yeah. By doing it that way, you still gave it an if-then statement. You're not incorrect because you did write it with a hypothesis and conclusion. It just so happened that by using the definition, we could disprove yours. Does that make sense? Please. All right. Now, here's where things start to get a little weird. There's actually names for all of these things. So you had what was called the conditional statement. P implies Q. Right? That's the logic. The second part of it is when you flip-flop them, the Q implies P. It's called the converse of a statement. So we have conditional. P implies Q. The converse is Q implies P. So like you did, we just did from last step. If two lines are perpendicular, then they intersect. If two lines intersect, then they are perpendicular. That's kind of what you were saying a second ago, but we agreed that yours wasn't necessarily true. Okay. Lines that intersect don't have to be perpendicular. So what we would do here is that we could state what's called a counterexample. A counterexample. A counterexample is anything that disproves a statement. Okay? A counterexample is anything that disproves a statement. Super, super simple. Move this out of the way real quick. So as we did, if two lines intersect, then they are perpendicular. That's written correctly as far as Q and P by flip-flopping it. But I could say a counterexample. They could intersect. Not perpendicular. That's a counterexample. They could be just like this. I could draw two lines. Counterexamples could be a diagram. Those are two lines that intersect and are perpendicular. If they're perpendicular, I put that little square box in there to show that it makes a right angle. So counterexamples can be a statement, be a little diagram, just to disprove something. Yes, ma'am. Yep, that's the definition. If lines are perpendicular, they make a right angle. They will intersect at one point, but more by being perpendicular, you are in fact a right angle. You are creating right angles. That's where that comes from. You have the opposite reciprocal slopes. They form 90-degree angles. If lines just intersect, they just intersect. Yes, sir. The converse was just flip-flopping them, saying it backwards. Q implies P. I try to use words and try to think of ways that are easy to remember. Just flip-flop it, say it backwards. The next one is called inverse. Oh, sorry. The inverse. And what we do with an inverse is we negate. When you negate something, you put the word not or no in front of it. So the inverse, sometimes you see it written like this. The inverse then, not P implies not Q. This weird looking bar with a line down, not P, implies not Q. That's just a term that mathematicians use for the word not. If you want to write not P, not Q, that's fine as well. That's the idea. So all you have to do is negate the first statement. So if we go back off the idea of if lines are perpendicular, then they intersect. That was our first statement, P to Q. Is that true or false? If lines are perpendicular, they intersect? That's true. So what we want to do is something like this. We know that that's going to be true. So I put a little T next to it. It's kind of the idea of what's called, we're going to start building what's called a truth table. So if I go to the next one, converse, I flip-flop it. Converse was Q implies P. We just did this one a little minute ago. If lines intersect, then they are perpendicular. Was that true or false? If lines intersect, they are perpendicular? Not all lines have to be perpendicular. Okay, remember again, we had that little, we can draw them out like this. So I would say this is false, and anytime you know that something is false, you have to give what's called a counterexample. So a minute ago, I said that you can make a statement or draw a picture. This is when I would just draw a picture of two lines intersecting, and they're not a right angle. That's a counterexample. Okay. Now the inverse, excuse me, the inverse goes back to the original statement. And all you have to do is put the word not in there twice. So if you follow through on that one, if lines are not perpendicular, then they do not intersect. See how that works? All you do is put the word not in there. If lines are not perpendicular, so this was not P implies not Q. If lines are not perpendicular, then they do not intersect. Is that true or false? False, right. That's also false because, well, they could intersect and not be perpendicular. Okay? A lot of times when you have a counterexample, you can reuse that counterexample for multiple pieces. I can use the exact same picture. That's fine. Just fine with that in. Excuse me. And then the last one is the weirdest name of it. It's called contrapositive. Contrapositive. Contrapositive is negating a converse. Not Q implies not P. So if you go back to the converse, if lines intersect, then they are perpendicular. I would say if lines do not intersect, then they are not perpendicular. See what I'm just putting the word not in there? Right, that's true. So not Q, not P. If lines do not intersect, then they are not perpendicular. Is that true or false? True. Because if lines don't intersect, that means they have to be parallel. Will parallel lines ever intersect? No. Nope. So you get true. What happens here, guys, with these truth tables is that if the first statement is true, your last statement is usually true. 99.99% of the time. If you start with a true statement, you'll end with a true statement. Depending upon what the statement is, it could be true in the middle, and it could be false in the middle. But if one of them is false, they're both usually false. And you start to go through these. I got a couple really easy examples to walk through on this one. It's really simple as you read through them. Okay? Not so terrible. Let's try it out here. Did that. If it's raining out, let's see, this is our conditional. Oops. Our P implies Q. If it's raining, then it's cloudy. Perfect take, right? P to Q. If it's raining, then it's cloudy. True or false? Rain generally falls from some sort of a cloud, but I agree, I know what you're talking about. Let's just say it's one giant cloud of gas. What is it then? What's in the sky that's holding the moisture in the air? Space has no space. If it's that is, it's one giant cloud. You don't have to overthink it like that. But yes, let's just say this is one giant cloud. Okay. So is that true or false? If it's raining, it's cloudy. True. Okay. Oops. So converse, it is flip-flopping. All right, flip it. If it's cloudy, then it's raining. Give me your counterexample. It's hard. It's a hard one to. I know what you mean, but you could just be cloudy out. It doesn't rain always when it's cloudy, I guess you can say. I think that's kind of what you're getting at. Right. That's the idea. That's a false statement. Okay. So if I go to the inverse, remember the inverse then is not P, not Q. And all you have to do is put the word not into the first statement. If it's not raining out, then it is not cloudy. Is that true or false? That's also false.
That's true.
If it's not raining, then it's not cloudy.
That's contradictory. No, it's not. Never mind. I just.
Yeah, if it's not raining, then it's not cloudy. That's also false. It could just be cloudy out. It could just be a cloudy day. It's plain and simple. Like I said, I'm trying to come up with something that's really, really easy to work with. And then the last one, the contrapositive, not Q, not P. If it's not cloudy, then it's not raining. Not Q, not P. If it's not cloudy, if it's not cloudy out, it's not raining out. True or false? True. It's not cloudy out, so if there's no clouds, then there would be no rain. What's that? You're hating this, aren't you? If it's not cloudy, then it's not raining. Converse, inverse, contrapositive. We always go in that order because there's a flow to it. Okay? We always go in that order because then it gets a nice, easy flow. What's that? So vertical angles are congruent. Let's take a minute. I want you guys to go through and write out all 4 of these. I try to make it real short. I'm sorry, what? We don't have school on Monday. Next week? No, next week we have. Oh yeah, this Friday we have 4-day. Yeah, we have 4-day weekend, and then next Wednesday is the SAT. It's Institute Day. SAT, PSAT for juniors.
Wait,
There's 4-day weekend this weekend. Next Wednesday, juniors only PSAT. What's up? Institute Day. Take a minute, write it out for those. Write it out for this one. Not the world's most difficult stuff. If you have vertical angles, then they are congruent. Is it okay to use symbols? Yes, ma'am. How'd you write it? And everybody's gonna might have something a little bit different. That's fine. If you have angles that are vertical, then they are congruent. Yeah, that's fine. Because, and this is where a lot of this comes into how you write out your first sentence. Okay? It doesn't have to be exactly like mine. Because now, if you guys said, would you say if angles are vertical, then they are congruent? I like that better than mine. If angles are vertical, I'm gonna change that out. If angles are vertical, then they are congruent. Okay. True or false? True. Okay. Next one was saying it backwards. If angles are congruent, then they are vertical. True or false? False. That's false. What's a counterexample to that? What's that? Is there such a thing as horizontal? How about this? We're talking about angles, right? Can I just draw an angle here and say it's 30 degrees and draw an angle over here that's 30 degrees? Those aren't vertical, are they? They're congruent, right? They don't necessarily have to be vertical. Okay. I think I know what you're going, but if you drew one, if you did this, can I do that? Those aren't vertical. I think that's kind of what you were thinking. Would that be an okay example? Sure, you just drew 2 90-degree angles. All right. That would be a counterexample. Anything that disproves the statement. Okay. Next. Not P, not Q. So if angles are not vertical, then they are not congruent. If angles are not congruent. Is that true or false? That's also false. Can I use, I can use that exact same counterexample from the one previous. Okay. Here's a 30-degree angle, here's a 30-degree angle. Those two guys are congruent, but they're not vertical. And the last one is what they call the contrapositive, that is the not Q, not P. If angles are not congruent, then they are not vertical. If angles are not congruent, they're not congruent, and they're not vertical. True or false? It's true. If the angles are not congruent, that means they can't be vertical. What's that? Right. Yeah. Well, they're not. If they're not congruent, then they're not going to be vertical. That's true because you can have angles that are not congruent. Correct. Because if they are vertical, they have to be congruent. But you can have angles that aren't congruent that aren't also vertical, so they can't be. Yeah. But they're not congruent, they're not vertical. Okay. Yeah, but if they're not congruent, see what I'm saying here? They're not congruent. If I do this, correct. These two angles are not congruent. This is 100, this is 80. They're not vertical, or excuse me, I messed up now. They're not congruent because they're not vertical. Just logic. Logic. Right? I think the only other stuff that we didn't really roll through that you might have missed out on. Those, and then on the first one, that was just finding out patterns. Yeah, the idea now of what a counterexample is, just showing that anything, to show you guys how things don't work, that kind of comes out now. So now, I'm hoping that it makes sense for the stuff that we assigned for you guys on Friday. Okay? So the assignment from Friday, I want you to add 3 more. Okay? So the stuff that we gave you on Friday, I want you to add those 3 to what you did. Okay? That was on the second page, page 94, I want to say. Yeah, that's on the page 93. Okay? So that's the page 93 stuff. So what does that? We'll just add those 3 problems to what you did on Friday. And then we'll collect all that tomorrow. Okay? And those 3 are just basically what we just did today, the converse, inverse, contrapositive. Make sure you write them out. That way you know which one's which. Okay? If they're false, you have a counterexample.